Hi everyone, so glad to have you here on the 15 days of SQL challenge, where every day for the 15 days, the past 12 days, and the upcoming 3 days, we have been coming here together and started our SQL journey, further solidified our foundations on whatever database knowledge we had. So, thank you for joining me here. If this is your first time, hi, I am Akriti. I am a data analyst working in the AI domain. And I'm also a part-time content creator on Twitter, and now I've started my journey on YouTube. Thank you for joining me in the initial days of my YouTube journey. Yesterday, what we discussed was what window functions are, where they are used, and we took an example of one specific window function, which was row number. What row number did was, based on some order, it gave a number to each row. Okay. So, SQL is very simple while giving the names to its functions. It makes sure that the name itself conveys what the function is trying to do. Row number, as the name conveys, is it will give a number to specific row. Now, how? So, we'd have to specify it while creating our window that you have to order by something. When you order by something, the rows are arranged on the order based off some column value, and then each row is given a number. Now, extending that concept itself, today we have ranks. There are two types of ranking window functions available, that is rank and dense rank. The whole concept behind how they work and what their syntax is very similar. There's just one slight difference between how they produce the results, and that's why they are different, and we'll see through examples how they are actually different. So now first, row number was giving a row, each row a number, and rank would rank the rows. This is similar, right? Giving number to each row based on some order and then ranking it. Ranking is kind of the same thing, which is providing a number. But what happens is, where rank differs from row number is, row number would not give same row numbers ever. That is, if it will arrange it one after the other, and it will give it in the chronological format. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whereas, how do we rank things? If you have two students having the same marks, you rank them similar, right? So if they both have the second rank, both of them would share the prize. Correct? It's not like you'd give them 1, 2, 3 based on it. No. You would have to give both of them the same rank. This is where rank is different from row number. Even though row number would give two same values, just exact same values, two different numbers, because it has to go in chronological format without any duplication, without any repetition. Whereas rank considers separate values and give those values a number. Okay. So if suppose I am trying to rank marks and I have one mark as 99, another student's mark as 98, third student's mark as 98, and fifth student marks as 96. So row number would go 1, 2, 3, 4, 5. Whereas how rank would go is, it will say every student with the mark 98 is rank 1. Every student with the mark 98 would have the rank 2. So the two students which have the same marks would get the same rank. However, if you give a row number, the row number would be different for them. So one would be 2, second would be 3. And it is assigned in a numerical random fashion based on what the order was. It does not look at the alphabetical wise or whatever. Whatever you have specified as the order by clause, it will just arrange it in that format and give it one by one the row numbers. Whereas rank, what it will do is, all of the same values will have the same rank. All the identical values will have the same rank itself. So let's try a question and see how let's first execute it and see how they differ. Also, I forgot to ask if my audio and video is proper. So if it is not, in any case, do let me know. What tutorial am I following is posted in the chat. I highly recommend opening it on your workstation and working side by side with it, because it is tech and it is not a theory lecture. It will never be. Is the environment ready? Yeah. So let's first see what the queries, whatever code they have given. Okay, I don't want the where clause, I don't want to filter my data. I want my data to be as is. Now what it is trying to do here is, like every window function, it has this over syntax. After the function call, it has to say over, which will specify what window, in which way you'll define it. The window can be defined in two ways. First is you give whether the window has to be divided into subgroups. You give that by partition by. You give a column after partition by. What it will do is it will create partitions based on that column value. So if start terminal is 1 and the other is 2. So all of the entries for the first start terminal would be together, and then the window function would work. For the start terminal 2, all of the entries would be together, and then the windowing function would do whatever it has to. Next part is order by. Why is order by required? Because if you don't tell by which column it should rank, then how would it be able to process it? What we are doing here is, first we are 3100 and we have, do we have another start column? Not in this. It is further dividing by start terminal values, and then within each group it is looking at the duration seconds and it is giving the ranking. Now you see here, for I think it is ranking by start time. Okay, so let's also see the start time here, so we are able to get a proper idea of how it is performing the ranking. We don't need the duration seconds. What it is doing is, it is dividing by start terminal first. It is creating further groups. Within that group, it is ordering by the start time and then giving rank. Now you see 1532 is the earliest time, so it has 1. After that we have 2nd January 1240, it is a rank 2. Then 2nd January 7:15 p.m. rank 3. Now we have 2 entries for 722 for 3rd January. You see these two, this and this are same. Since they are same, they have gotten the same rank, because what rank does is, it doesn't care about which row they occur in, it cares about what the value has. So it will give all of the values, identical values, the same rank, as opposed to if on the same thing we have a row number. I'll perform the same function. I'll perform the partition using my start terminal, and I will have my ordering by the start time. But still you will see how different the results are generated. Oh, because there's a comma missing here. Whenever you're getting select queries, you have to separate all of the columns with a comma, otherwise you'll end up here and get an error. Now you see, for the singular unique values, we have rank 1, row number 1, second rank 2, row number 2, rank 3, row number 3. Now rank 4, row number 4, still the rank is 4 because the value was same, 722, but the row number has increased by 1. Why? Because the row number does not care about the value, it cares about how the rows are occurring, and it will assign a number to each row. Okay, it is row specific, whereas rank is value specific. It will give all of the values which are identical the same rank. 722 was the same value, so they got the same rank, whereas they were different rows, so they got the different row number. So while implementing these concepts on some question, you need to make sure what is the context you are using them. If you want to give them just a number, you want to tag the row as something, you would be using the row number. But if you want to rank values, make sure that you use rank, because rank would give the numbers assigned rank on the basis of value and not on the basis of row. Now one next thing what you'd notice is, after that there was 4 here. The next value was 3rd January 1232, which was the next rank. It did not get the 5th rank. It again shifted to 6th. Why? Because the 4th rank had 2 rows. So now it has skipped the 5th rank and it has again the 6th rank. So this happens while ranking in certain tournaments also, that if 2 players are getting the same rank, then the next rank is omitted. Now you had 1, 2, 3, but 2 rows were 4, so next was skipped. If there were 3 rows 4, then 5 and 6 both would get skipped. If there were 5 rows which were 4, so after 4, 5, 6, 7, 8, all of them would be skipped and the next rank would directly be 9. So keep this in mind while you are putting the rank, that it gives 2 rows which have the same value as the same rank, and it would skip over the next rank. If it is giving more than 1 row the same rank, then those many extra rows, extra ranks would be skipped entirely. They would not be used while ranking the rest of the columns, the rest of the rows. Clear? Now this changes when we have another ranking function, right? What is that ranking function? It is called dense rank. Okay? This is also required somewhere. Just today I was solving an SQL question and it specified that it should not be like that some rank is getting skipped. Okay? So here the rank 5 got skipped because here you see 10, 10 were repeated. So 11 was skipped. Ideally after 10 you should have gotten 11. But since 2 took the same rank, so 11 was skipped. After 11 you had 12. So 12 also 2 took, so 12, 13, 13 was skipped. You had again 14, then 15, 15. 15 took the place of 16 because there were 2 15. So 16 was skipped. And so on we have. Now if you have certain applications where you don't want this rank skipping to happen, okay? You have some application and you want the rank to be continuous. And in case of any identical values, the duplicating of rank also, the next rank should not get skipped. What should you do in that case? So in that case, the function to use is dense rank. It will have the same syntax. All window functions have the same syntax. You specify the function name, then you say over, and then you define your window. You can perform the partition over the window and then order it, or you can skip it or just order it for the rank. In case you don't want to categorize it based on some column, you can skip the partition by part. You can just give the order and the ranking would happen according to that column values order. Okay? Now let's see how dense rank and rank differ. Here you see 1, 2, 2, 3, 3, everything is matching. Now while providing the rank, 722 is same, so it is getting the value 4, 4, because all of the ranking happens on the basis of a value. That value had the rank 4, so no matter how many times, how many rows that value has, it will still have the same rank. So 4, 4, 4, 4. However, our usual rank was skipping over the next value in case the previous value was repeated, whereas dense rank keeps it continuous. So even if there was a continuous 4 4, the next value was still 5. 5 6 7 8 9 9. Even though 9 got repeated twice, the next value was not skipped and it was maintained. After that we again had 10 tab. This is the main difference between rank and dense rank. They perform the ranking in the same fashion, whereas while writing the rank function skips over in case of any duplication of rank, whereas dense rank keeps the ranking continuous. Okay, so that's the theory part of it. Next we have to try a practice problem. What the practice problem says is, write a query that shows the 5 longest rides from each starting terminal, ordered by terminal, and longest to shortest ride within each terminal. Limit to rides that occur before January 8, 2012. Okay, so we have a lot to process here, I feel. Let's go one by one and not get intimidated by the wordings of the question, because oftentimes when you start decoding it, it is actually simpler than it looked in the first read. Okay, let's first start. What do we want to see is the longest ride, correct? What is our table? First of all, I need to look at the table in order to get what we are trying to find. So select star and let's print. First take an overview of what the table contents are like. So we have duration in seconds, start time, start station, start terminal, end terminal, bike number, rider type, etc. Okay. Now what it wants is, let's go one by one. 5 longest rides. So when we have to, now again, if it is saying longest rides, we know that we have to rank something. Now on the basis of what? We'll see now. From each starting terminal. Okay. So each starting terminal, once we have to do a partition. So let's first get the longest rides. I guess we'll be getting the duration in seconds then, because there is no ride name or something. So we'll get the duration in seconds. Okay, and now we'll perform whatever rank we want to. So I'll write my function name, then define my window using the over. How we do that is, first look at what the question demands. It starts from each starting terminal. That is, we have to limit our 5 longest rides for each terminal. So our scope while calculating the longest rides would be just that terminal. At one point of time, we would only be processing the values within one terminal in order to get what we want to. So we know that we cannot perform the function, the calculation to the entire data set at once. We want it for each terminal. So we'll be doing our partition as partition by, and we'll do so by starting terminal, start terminal, and we'll order by terminal. How can someone order by terminal? Order by terminal. I don't understand how one can order by terminal, because it is the name and it is happening within a terminal. I think they'll ordered by terminal and longest to shortest rides within each terminal. Okay, so we are having for each terminal. Now we'll have to order it by something. How would we order by? We are saying longest to shortest. So we'll order by duration seconds. But since we want longest to shortest, what we'll be doing is we'll do the descending order, because that's how we'll get the longest rides ranked first and the shortest rides ranked last, if we perform the ranking in a descending fashion. So we'll perform the rank for each terminal, each start terminal, and how will we order it? So using the duration the ride took in a descending fashion, because we want the longest rides first and the shortest rides last. Cool. I think this is the ranks. And it had one more thing, that the rides should be before January 8, 2012. So we'll have to say that their start time, the start time is before your limit to, or yeah, so occurred before, not including. So we'll not use the equal to sign. This is a where clause, and where clause takes a condition to filter the rows based on whether that condition evaluates to true or not for that particular row. Here the condition is that the rights should occur before 8th Jan 2012. So we will write 2012 8 January, right? And now it will rank. I hope it works. Okay, now we should also print the start terminal, so we are able to see that for each terminal what is happening. Now see, for the start terminal 3100, the longest ride was 3340 of 3340 seconds. So it was ranked first. Then the next ride was 2661 seconds. It was ranked second. And so on. You had till 16 ranks. The shortest was 74 seconds, which is just a little bit over 1 minute. And then after that you have the next start terminal, which had the longest ride as 3624. So for that start terminal you got the ranking separately, and here the longest ride was 3624 and its rank was 1. So you see, when we are performing the partition, the ranking is only happening within that particular subgroup. So the partition here was the start terminal. So it performed the categorization on the terminals. 3100 was one group, 3101 was another group. The ranking only happened for those rows, keeping only those rows in mind with respect to those rows, not the entire data set. For 3100 we had 16 rides and it ranked it equivalently. Then it moved on to the 3101 start terminal and started ranking its rides based on the duration in seconds in a descending fashion. So the longest rides, or the highest number of duration seconds, was ranked the first, and then it went on till rank 59, which was a 5-second ride. Then again the partition moved to another start terminal value, which was 3102. Then only those rows were ranked. So here it was 41,427 and the ranking was given for that particular terminal. As opposed to when we had performed our usual, select this, group by and then order by, it won't do it within a group. The order by is universal. So it will work, it will order on the basis of all of the values present in the data set. When we want to limit our scope to a particular window, we have to use this window function rank. Now it said that it does not want all of the values. It said that it only wanted the 5 longest rides. Correct? So first of all, now that it wants the 5 longest rides, I have to use dense rank in place of rank. Why? Because rank would consider even the next value to not be 5, even though it is. Let's start here and then I'll tell you what I was thinking. Now I want the rank to be limited to 5. So I will use whatever we did till now as a subquery, import everything from that. But I will place a filtering condition that my ranking, the rank's value should be less than or equal to 5. Okay. Why so? Because I only want the top 5 longest rides. I don't want anything after that. Oh, what happened? Oh, it needs an alias. Is it? Yeah. My alias is B. Whenever you are passing a subquery as a from clause, you need to give it an alias, which I did not, which I often forget giving. So it throws an error and then I immediately regret. Hi Lucio, nice to have you here. Now you see, from each of the starting terminals, you are only getting the top 5 rides in place of the total rides, like 18 rides, 59 rides from each terminal which you get. You're only getting the top 5 ones. So 1, 2, 3, 4, 5. And these are the rides which we have. Right? For this again, we have 1, 2, 3, 4, 5. For this again, we have 1, 2, 3, 4, 5. So we only have the top 5 rides which have been ranked under the value 5. So we performed this filtering condition. What it did was, wherever the rank was greater than 5, it discarded that row. It did not consider that row as a part of the result, giving us just the top 5 rights. Okay, let's compare it with the answer. Yeah, I think it was pretty much the same thing. Their rank partition by they're getting the start terminal, duration seconds descending, and then they're filtering less than 5. I think it's the same thing what we have done. Yeah, so that is us solving the question, and I hope the concept of rank and dense rank and how it is different from it is difficult, it might be. I hope I helped a little bit, but I hope you understood how it is different from row number and how we could implement it as a window function. Why is it necessary? Why can't we use our normal order by clause to perform this operation? Because what rank does is it can operate on subgroups as well, and within that subgroup it will order it and give it a value. What rank does is, in case there's a duplication in the rank because of same values, identical values, it will skip over the next rank, whereas dense rank solves that query and it will keep the ranks continuous even in case of duplication. Okay, I hope this was clear and you had a good time joining this. Rank less than no, Umesh, I cannot add it in the subquery, because why, I'll tell you. Because what happens is, while SQL is trying to execute the query, it executes all of this filtering and ordering first, and then it selects. So your ranking is a part of the select statement, right? First it will do everything present down, and then it will select it and create your rank column. So if I had put the rank less than equal to minus 5 here, less than equal to 5 here, SQL won't know that there is a rank column, because this statement would get executed before the select part. it won't know till then that there is going to be a ranks column and it won't have its value. So you won't be able to perform that filtering operation within the subquery. For that, you would have to first import all of the columns here. And now that you're importing them from this database, now SQL knows that there is a column named rank and it can perform that filtering function, as opposed to in the subquery itself where SQL wasn't aware and it was yet to process that ranking in order to get the ranks column. So the performing the filtering in the subquery was not possible. Hi Vikash, the SQL book is still in works and I'm looking for reviewers to first give me feedback on it and try to make it more readable and better for you all, and then I'll publish it and I'll ping you. I'll tell everywhere that I am publishing my book. Don't worry. But thank you. Thanks for checking in on that. It really gives me the motivation to work on it more. Thanks for joining, everyone. If you have any doubts, feel free to add it in the chat or the comments. I am very active on Twitter itself, so you can tag me there. And thank you for joining me in this 15 days of SQL journey. We are coming to an end very soon, and I hope it added some value to your data analysis journey. Thanks for joining. Bye.